Good morning my dear students and welcome back to our physics class. And in the last class we completed the chapter force and pressure, right? So hope you all studied that well, and you should study well because your midterm exams are coming, right? So because of this reason I have to go a little more faster. So we have to cover a lot of portion, right? So you should do the exercise given in your textbooks, that is in page number 142 from the chapter force and pressure, right? So you should try to do the exercise. If you have any doubt you can ask me and I will clear it through WhatsApp, right? So today we are going to discuss a fresh topic or a fresh lesson, that is your second chapter, friction, right? What is this? Friction. You have already know what is friction. We studied it in the previous classes, that is in the previous chapter, force and pressure. That is, friction is a contact force, right? So what is friction? Simply we can say, what is friction? Friction is a opposing force. Or how it become a contact force? It acts between two surfaces, right? So here you have to, we have to study more detail about friction, right? So it is given in your textbook, that is you might have seen a driver of a car or truck slowing down the vehicle at a traffic signal, and you also apply brake on your bicycle when it needs to be slowed or it needs to be stopped, right? So here it is given in your textbook. So many examples are given for you to understand how the friction is acting, or how the friction helps us, or how the friction become an evil to us. All these things are given in your textbooks with examples, with suitable examples, right? So we have to study in detail about friction, right? And in the introduction part it is asked that why the vehicle slows down when we are applying a brake on it, or how the moving objects, that is not only vehicles, any object moving over the surface of another object slows down when no external force is applied on it. How these things happen? We have already discussed all these things. That is, when we are discussing the friction under contact force, we said that in the case of a moving ball, right, when kicking a ball it moves forward, and after some time it comes to rest by its own, right? Nobody didn't take any obstacle in front of the ball to make it rest, right? So how it become, or how it comes to rest by its own? Because of friction, right? A frictional force is acting opposite to that of the motion of that ball, right? So that the ball comes to rest after some time, right? So here some more examples are given. That is why it is difficult to walk on a smooth or a wet floor, and a boy falls down when he steps on a banana peel. These all things happens. All these situations explains the effect of friction, right? We have to, we can walk through the wall, or we can walk through the surface of earth because of friction. Unless it is acted by a friction, we cannot walk through the floor, right? That is, in smooth surfaces the friction is less, and we feel some difficult to walk through the smooth or extremely smooth surfaces, right? And it is happen in the case of a boy falls down, he steps on a banana peel. Banana peel is extremely smooth. When he steps on it, there will be no friction, so that he cannot walk, or he will fall down, right? So all these things we have to discuss in detail. And here in the first activity 12.1 is given, us to understand what is friction or how the friction is acting on two surfaces, right? So the activity is generally push a book on a table and you observe that it stops after moving for some distance. Repeat the activity pushing the book from the opposite direction. Also this will make what? The book comes to rest after some time while moving some distance, right? So what we can infer from this? That is force of friction, or friction is always acting opposite to that of the applied force, or we can say friction opposes the relative motion between the surfaces, right? That is in this activity friction is opposes the relative motion between the surfaces of book and table, right? While we are pushing the book on forward direction, the friction is acting on opposite direction. That means it pulls the frictional force pulls the or push the book backward, right? So that it will comes to rest. That is when the frictional force and the applied force become equal, the book comes to rest, right? So in this activity it is said that the friction opposes the relative motion between the surfaces of the book and table. That is only the thing, that is friction is an opposing force, right? This thing we have already known, right? Opposing force. Friction is an opposing force. Okay. And now we have to discuss what are the factors affecting friction. That is the friction is same for smooth surface and same for rough surface. We already know it is different for different surfaces, right? So we have to look what are the factors affecting friction, right? So here we are discussing the factors affecting friction. So what do you think? What are the factors? What may be the factors? One thing is the smoothness of surface in contact. That is, you have already know we cannot walk through, or we are not able to walk through extremely smooth surface, right? Extremely smooth surface in the sense is not, it's an hypothetical condition only. There is no extremely smooth surface. Even if there is a smooth surface, there may be some irregularities or there may be some kind of some sort of friction, right? So we can say for extremely smooth surfaces friction is 0 or there is no friction. It's only an hypothetical condition. You should know that, right? And to study the friction or to study the factors affecting friction, we can say for extremely smooth surfaces there is no friction, right? And for rough surfaces friction is larger, right? So it is more clear, it will be more clear by doing this activity 12.2. That is, in this activity what they said, tie a string around a brick. You take a brick and tie a string around it and pull the brick by spring balance. You know what is spring balance? Spring balance, it is given. You may see that the spring balance in markets, or what it is used for lifting heavy loads, or it is given here. Spring balance is a device used for measuring the force acting on an object. It consists of coiled spring. You can see here the photo is also given here. What is spring balance, right? So by using a spring balance we can measure the force acting on an object. So tie a string around a brick. Suppose this is a brick. Tie a string around this brick and try to move it. Try to pull the brick by a spring balance, right? So we have to need some force to move this brick. right? And you should note that what is the reading of spring balance by pulling that brick, okay? And after this, tie or wrap a piece of polythene cover around the brick and repeat the process or repeat the activity, right? And there may be a change in the value of the reading given by the spring balance, right? So what will be the reason? So, and what will be the reading? What is the change in reading? The first reading, that is without wrapping a piece of polythene, the force become more, right? So we have to apply some more force to move the brick, and while wrapping the brick by polythene cover, we have to apply little less force to move the brick, right? So why it implies, what it implies, why it is so? Because the polythene cover has some more smooth, right? Somewhat smooth. It has some smooth surface, so it will move easily, okay? So while wrapping a piece of polythene, the brick will move easily. That means there is less friction. And repeat the process, repeat the activity by wrapping a piece of jute bag around the brick. What do you observe? Jute bag is somewhat rough than what? Polythene cover. So the reading of the spring balance become more when compared to the polythene wrapping polythene cover, and without any polythene cover or without jute, it may be, but the reading is higher for in first case. So if you got a spring balance, you can do this activity by your own, right? So what this activity tells us, the roughness of or the smoothness of the surface determine how friction acts, right? So the smoothness of surface in contact is a factor that affects friction. Smoothness of surface in contact is one factor that affects friction or what that determines friction, right? So it is what it says, smooth surface have what? Less friction, and rough surface have more friction. Okay, these all things you have already know, right? That is because this thing, smooth surface has less friction because of this thing, but we cannot walk through extremely smooth surfaces, right? Or when some oil or water is spread on the floor, we will lie down, right? So that is smooth surface will give less friction and rough surface will give more friction, right? And one more activity is given to you, and you can do this. This also indicates how the roughness and the smoothness affect the friction, right? This also gives this example, or this activity 12.3 is also suggesting this thing, or what are the factors affecting smoothness, what are the factors affecting friction, that is smoothness of the surface in contact, right? And what are the other thing? One more is, the second thing is how tightly the surfaces are held. And one more thing I have to say, how this friction comes into play. That is, two surfaces are in contact. When two surfaces are in contact, they will make what? The surfaces have some irregularities, right? All the surfaces have some irregularities, and these irregularities causes the friction. That is, friction is caused by the irregularities on the two surfaces in contact. That is, suppose it is given in the case of book and table, the surface of book is somewhat, I can wipe this. The surface of the extremely microscopic view of the surface of book is somewhat here, and it is the surface of what? It is the surface of book, and it is table, right? So there may be some irregularities on both surfaces, right? Every surfaces have some irregularities, and when these two are in contact, these irregularities will make an interlocking, right? Interlocking. This will cause the friction, right? So how the friction is coming to play? The irregularities make the friction. That means the friction is caused by the irregularities on two surfaces. Even though the surface is more smoother, it has some irregularities, right? So irregularities on the two surfaces lock into one another. That is, it lock into one another. And when we attempt to move any surface, we have to apply force to overcome this interlocking. That is, if a book is placed here, suppose this is the table, or you can see this also, this is a duster, this is a chalk. So this chalk surface has some irregularities, and also this duster surface has some irregularities. So that is because it is tightly held here, right? So to move this chalk piece, we have to apply some force to overcome this interlocking. That is, this surface and this surface, these irregularities are interlocked together, right? So we have to apply some force to move this chalk piece. Okay. So to overcome this interlocking, we have to apply some force, right? And so the force of friction is greater in case of rough surface. That means rough surface have more irregularities, okay, and smooth surface have somewhat less irregularities. Okay, so what are the factors? The smoothness of the surface affect the friction. How it affects? That the smooth surface have less irregularities, and the interlocking is smaller in case of smooth surface, and in the rough surface the interlocking is more and friction is more, right? So we have to apply more force to overcome this interlocking and more force to overcome the frictional force in the case of rough surfaces, right? So this is all about how the friction acting, or how the factors affecting friction. And one more thing, how tightly the surfaces are held together. That means suppose this is one surface, suppose it is a table, and there is another object, like it is placed like here, okay. So this is the contact surfaces. That is, this surface of one object, and this is the another surface, right? So here is what there may be an interlocking, and there may be a friction acting on these two surfaces. And in the second scenario, we have what? This another object like this. So here the contact surface become what? Somewhat larger. That means some more tightly it is packed. It is packed more tightly while compared to this, right? So there may be a greater friction acting on these two surfaces, right? And one more scenario we can take, that is like this, okay. So here it is packed more tightly, that is all the surface, the how long it is pressed. That is, here the friction is greater in all these cases, right? So this is the order of friction. That is how tightly the surfaces are packed is another thing that determines friction, right? So this is less tightly packed and it is somewhat tightly packed. It is more tightly packed, right? So here it is, the friction is greater in so when compared to these two cases, right? So these are the factors affecting what? Friction. How tightly the surfaces are packed and how smooth how smoother or how rough the surfaces. That things determines the frictional force, or these are two things that determines frictional force, right? So here it is, you should underline the things. Friction is caused by the irregularities on the two surfaces in contact. You should underline that thing, and you should also underline here the force of friction is greater in in rough surfaces involved, right? What you should underline? Friction is caused by the irregularities on two surfaces in contact, and one more thing you have to underline, the force of friction is greater if the rough surface is involved, right? And you should know, if the surface is smooth, friction is less, right? And one more thing you should underline from where it is obvious that, the next page 149, it is obvious that the force of friction will increase if the two surfaces are pressed harder. That is in the case of this, right? Pressed harder means more tightly it is packed, right? So it is obvious that the force of friction will increase if two surfaces are pressed harder. You should underline that also. Okay. So these are the two factors affecting what? Friction. Okay. So these are the things. What are the things we have discussed today? We have to discuss more about friction, that is about what type of friction, static friction, sliding friction, rolling friction, and how these frictions, frictional force differ in value. That all things we have to discuss in detail, right? So we can discuss that in later classes, right? So today we are wind upping with this, and we can meet in the next class. Okay, thank you.